Hi, grade 8 students. This is day 19. We're looking at page 526. We're studying the prefixes on that page. 530, numbers 9 through 33, and then 37 through 43, and it's the odds for all of these problems. Before we get started, please read through 527, 528, and 529. Pause this video to do that and then come back and we'll take a look at some examples of this kind of work. Okay, so there's a couple of yellow highlighted terms here. One of them is polygon, one of them is diagonal, one of them is an interior angle, and finally one of them is a regular polygon. We're going to spend some time talking about these so that hopefully you can get through the lesson. I don't think you're going to find it too challenging, but let's see how it goes. As you know, starting on the left side here, when we take a protractor and we measure all three angles of a triangle, let's say this is triangle ABC, angle A and angle B and angle C always have to equal 180 degrees when we add them up. And we've also said that if we have four angles, like what we see in a quadrilateral, that adds up to equal 360 degrees. Now, the question is why? Your book spends some time talking about the fact that this is, of course, a triangle, and that this quadrilateral can be divided into two triangles using what's known as a diagonal. And because it's two triangles, it's 180 degrees and 180 degrees to make that 360. And then they try to talk to you about doing the same thing with a five-sided figure, a pentagon. And a pentagon can, notice the diagonals only go from one vertex, but we've created three triangles here, and so that's 180 plus 180 plus 180. So pentagons have 540 degrees when you add up the sum of their interior angles. All five of these angles has to equal 540. Why? Because it's 180 plus 180 plus 180. If we do the same thing with a six-sided figure, a hexagon, you can see that there's now four triangles. 1, 2, 3, 4 triangles here. So that would be four groups of 180, or in other words, a hexagon, when you think about all of the interior angles, and there's 6 of them, if you add them up, they should all equal 720 degrees. Now, that leads us to these kind of strange formulas over here that we'll be using later on. The n in these two formulas represents the amount of sides that a particular polygon has. So if we know the amount of sides of any particular polygon, and we subtract from it the number 2, and we multiply it by 180, that'll tell us how many degrees the sum of all the interior angles would have. So let's go back to this set of diagrams here. This is 6 sides. So if we take 6 minus 2 times 180, that's the number 4 times 180, or that's that 720 we got right here. In this case, it's a 5-sided figure, so it's 5 minus 2 times 180, or 3 times 180, or 540. It's just the top formula. It's just a fancy way of finding the amount of degrees of all of the angles that are present inside that particular polygon when it has n amount of sides. Now, what's this formula all about? It's very similar. The only difference is we're dividing by the amount of sides, n. That would be a situation like this. If we have a regular pentagon, And by regular pentagon, hopefully by now you realize that that means all 5 sides have to theoretically be the same length. This formula can tell us the measure of just one of the angles in a particular polygon, such as this one. Because if we know we have a 5-sided object, and we fill in the 5 in all of the spaces where there is an n, we should get the measure of each one of these particular angles. So 3 times 180 is 540. 540 divided by 5, 108. Each one of these angles should be 108 degrees if the pentagon's regular. In other words, if the pentagon has 5 sides that are exactly equal in length and 5 equal angles. And that's what the discussion was all about on 528, 529, and 527. There was one other concept they talked about that I don't think we've made mention of here. The difference between a regular polygon and a polygon that's not regular. Remember, a regular polygon has all the sides the same length and all of the angles the same size. A not regular polygon would not have that same situation. Let's look at some example problems on 529 and see if we can apply. Whoops, don't want to erase that. Let's keep that. Sorry. But let's get rid of this stuff maybe. Let's look at problem 4. Classify the polygon, then determine whether it appears to be regular or not regular. Problem 4, to classify it, I'm going to add up all the sides. Number 4 has 5 sides. On page 526, we were told that a 5-sided object is called a pentagon. So that's my first answer for number 4. The second thing it says, we need to describe it as being regular or not regular. Well, in this case, I would call it not regular. Why? Because all of the sides are not the same length and all of the angles are not the same degree measurement. Let's look at number 6. Nope, number 5 rather, I'm sorry. Number 5, that is an octagon. How do I know that? Because it has 8 sides. And I would call it a regular octagon because all of the sides to me appear to be the same size and all of the angles appear to be the same angle length. Let's go to the next page. Let's look at 15 through 20. I'm going to pick problem 6. Problem 6. No, that was dumb. Problem 16 rather, problem 16. For problems 15 through 20, you're going to want to use this particular formula right here, the one that says n minus 2 times 180. So in solving problem 16, I know that an octagon has 8 sides. So I simply take and fill in an 8 where the n is and solve this formula. 6 times 180 is 0, 8, 1,000, boom, 1,080. So problem 16 is that answer. Again, we're using this formula for problem 15 through 20 because we're trying to find out how many degrees we would have if we added up all 8 angles of an octagon. How about problems 23 through 28? For problems 23 to 28, I would use this formula right here, down here. So let's try 24, where they're talking, no, I already did number 24. Let's try number 26, a regular decagon. What do they mean by a regular decagon? A regular decagon is a polygon that has 10 sides. So I'm going to use this formula, 10 minus 2 times 180 divided by 10, to find out the measure of one particular angle if the shape we're looking at is a regular 10-sided polygon, or in other words, a decagon. 10 minus 2 is 8. 8 times 180 is, I don't know, 0, 4, 6, 1440. 1440 divided by 10 is 144 degrees. So if I have a regular decagon, each one of the angles of that regular decagon has to be 144 degrees. Okay, I hope this helps you, ladies. If you have any questions, please give me a call. Thank you and have a good day. My number is still 517-242-3138.